Hello, I'm Tingting from Shandong University. My topic is data-driven macro-orientation for trend estimation in scatterplots. Scatterplots may appear on paper or electronic devices. They are often used to communicate trends. Directly showing trend lines in scatterplots is a clear way to indicate trends. However, the model enforced by such trend lines might be inappropriate for some data. Here is a famous example. You may consider that the trend patterns are quite different. However, with an improper model, the calculated trend lines are just the same. Even with a proper model, viewers may not have enough expertise to interpret the trend lines. Recent evidence suggests that people can use the area of the ellipse or the average length of the edges on MST to estimate and compare the correlations of the scatterplots. We wonder if markshape can also help with assessment tasks. With so many options, we focus on triangles and circles, which are the most widely used marks. This is a scatterplot with circles. You may fit it like the yellow line. But if we replace the mark with the upward triangle, will it encourage us to move our estimate up like the green line? So the question is, will the mark orientation guide or mislead the trend estimation in scatterplots? Initial work suggests that people are able to perform a general sort of regression by eye with simple Gaussian stimuli and a single class of outliers. How about more complex scenarios, such as scatterplots with different mark orientations and those with different data distributions? How mark orientation and data distributions affect trend estimation? And are there any interactive effects between these two factors? In this work, we conducted 3 experiments. In the first experiment, we generate the data of simple Gaussian stimuli with variables of different bandwidths and slopes. Then we study the data violate ordinary least square assumptions due to outliers in experiment 2, or non-uniform data densities in experiment 3, and for each trail, we set different mark orientations. We asked users to adjust orientation of the trend line and the y-intercept with 2 independent sliders. And for each trail, we measured the errors in degree with respect to the orientation, value with respect to the y-intercept. This is the result for the impact of mark orientation on trend estimation in the first 2 experiments. You may say that when a trend in the data is unambiguous, either due to strong correlation like A and B, or the presence of an obviously outlying cluster like C and D, mark orientation does not greatly impact the perception of trends. However, when trends are ambiguous, mark orientation can introduce a bias. We can get viewers to more accurate estimates of weak trends, like E and F, or trends impacted by nearby outliers, like G and H. This is the result of the interaction between trend slopes and mark orientations in experiment 3. We can see that the difference of the estimated mean orientations between the marks rapidly decreases as the slopes increases. Our conclusion is that participants are sensitive to features like disparate outlying clusters and local densities. We also find that in cases where the trend is ambiguous or uncertain, data-driven marks can be used to influence trend estimates. Thanks for listening. Details and data can be found from these links.